So, hi guys, welcome to day 12 of solving CSES graph series. So, today we'll be solving the problem cycle finding. So, let's read the problem. You are given back the graph, and your task is to find out if it contains a negative cycle and as give an example of such a cycle. So, the input goes like the first input has two integers n and m, number of nodes and edges. The nodes are numbered from 1 to n. After this, the input has different lines of describing the edges, and it's pretty much standard. Okay, A to B and with length is C. So if it does contain a negative cycle, we have to print yes, and we have to print the cycle, and if it does not, we have to print no. So we can see here that we can have negative edges, and when there is a negative is a negative cycle, I think the first thing that should come to our mind is Bellman Ford algorithm. Okay, because the extra fails here. So obviously, where will you go? So you'll go for Bellman Ford. Okay, so I think the idea for the Bellman Ford algorithm is pretty much standard. That basically what we do is we relax all the nodes up to the n minus one times, and we again relax for the nth time. And if we see if some else is getting relaxed, it does mean that okay, it does contain a negative cycle. Because what should happen in the ideal scenario is that in n minus one loops, it should get all the nodes should have their shortest path. So if it is getting changed in nth step, you will have can say that it does contain negative cycle. If you want to read much about it, I will say you to read here the Bellman for algorithm. Okay, and the case of negative cycle, it is given here. So you can see that they have used x equals to minus one, and they are replacing x. So they did till uh, n minus 1, 0 to n, it means n times. And obviously, when you check that x is still minus 1, it means that for the nth time, it does not get updated because you're resetting, okay, here, always. So, but if it is not minus 1, does contain a negative cycle, and you have to trace the cycle. This part is that let's say you are out of that negative cycle, you can come back to the negative cycle by tracing back through the parent array, and then you can, as we have learned in previous discussions, how to trace back our path through the parent array and then reverse it and print the path. So that's pretty much standard here. So yeah, so this is pretty much that we are going to do. So I guess let's start coding. So first we will take uh, input. So N and M is there. Okay. And for the edges, there is too much things. So you can make structure, you can make triplet and it and many more things. But let's make it simple, and let's make as vector of vector. Okay. Then one is a vector of L that will list. Okay. And another for to store the parent. It says relaxant. Okay. Because it relaxes all other the nodes. So, and it's pretty much famous terminology when we talk in Dijkstra and Bellman Ford algorithm. Okay, so yeah, so let's take the input. It is n and m, and uh, assign as n plus one, every distance as zero, because we can start from any place. Okay, and relaxant, that is. I think it is a parent. Okay, so we can assign it as n plus one and minus one, because initially we don't know how many parent is minus one. Okay, and resize. Yeah, so S is not resize n plus one, I guess. So yeah, and then we take the no, not n plus one, only m, right? Because we have only m. So why n plus one? Now we will take the input I equals to zero, I less than m, I plus plus. Three things are there: A, B, C, and we'll take in A, B, and C. And yeah, edges of I dot push back. Not as I have to push back. As if I equals to u v and stuff. Yeah. If we are storing in vector of vector, that's how it comes into the package. Okay. So yeah, that's pretty much standard way. And I just call the BFS. Let's say Bellman Ford. Let's try Bellman Ford and just call it. Yeah. And we'll write the Bellman Ford here, I guess. So yeah, I guess that's right. It will say BFS type algorithm where I guess the idea is pretty much clear as it could. So let's make his X. As I have shown you guys, I will do like the same, okay? I will perform it 10 times, and you can see every time I'll be resetting it to -1, okay? Let's get some gap here. Yeah, I reset to -1 and then I come to relax. So for auto and E in the edges, so stop relaxing. Okay, so what is U? U is E of 0. What is V? V is E of 1. And what is W? It's weight. So weight, or you can say distance. Okay, so E of 2. Okay, so this is called relaxing, that if this of U plus D is less than dist of V. So we can change the dist of V as dist of U plus D. हमने relax कर दिया dist of V को through U. Okay, so yeah, that's pretty much say as relaxation state, and relaxation of V will be with this parent of V, that is U. Okay, pardon my fake accent. Next equals to V or any number. Okay, so yeah, so after n iterations, if we have x equals to -1, it means last time it didn't get changed, so we don't have any cycle. We'll just print it no and then there. Else we got a cycle. So it can happen that we are not in the cycle. Okay, so we have some other edge that is getting relaxed. So, but yeah, we do know that it has a negative cycle. So if we be inside the negative cycle, what happens is that we will for L equals to 1 less than equals to n. I'll replace the x equals to the relaxant of x. Okay, so that I'm gonna perform it. I think it will be more clear if you read this here. Okay, if you read this here, that moreover, if such cycle is found, the Bellman Ford algorithm can be modified so that it retrieves the cycle as a sequence of vertices contained. For this, sufficient to remember the last vertex x, for which there is a relaxation in nth phase. This vertex will either lie on the negative cycle or is reachable from it. Okay, you get the vertices that are guaranteed to lie on the negative cycle, starting from vertex x pass through vertices n times. In this way, we will get to the vertex y, which is guaranteed to lie on negative cycle. We have to go from this vertex to the predecessor until we get back from the vertex, get back to the same vertex y, and will happen because it lacks the same negative cycle block in circular manner. So yeah, यही हमने किया कि अगर वो नेगेटिव साइकिल का हिस्सा नहीं है लेकिन साइकिल में जा सकते हैं, तो हम ऑब्वियसली हम क्या करेंगे कि 10 टाइम्स कर देंगे टू गेट श्योर कि हाँ भाई यहाँ से तो हमें मिल ही जाएगा। अब बस वेक्टर ऑफ एल साइकिल जहाँ पे हम स्टोर करने वाले हैं, एंड वी यू कैन सी हियर इन्होंने कैसे किया है। सो फॉर एल का इक्वल्स टू वाई, सो हम क्या करेंगे फॉर एल वी इक्वल्स टू एक्स, डबल सेमीकोलन का हम यूज करेंगे ताकि इन्फिनिट चलते रहे जब तक हम ब्रेक का इस्तेमाल ना करें, तो चलते रहो। वी इक्वल्स टू रिलैक्सेंट ऑफ वी। ओके, and I guess we'll just push back, cycle dot push back v. Yeah, if v equals to x, that it again and cycle dot length equals to is greater than 1, क्योंकि पहली बार तो ऑब्वियसली x ही होगा, तो तब नहीं रुकना, तो तुम ब्रेक कर जाओ. ओके, एंड it does mean that uh, our cycle is complete and we just reverse it because हम पेरेंट्स होते हुए गए हैं. आई थिंक हमने पहले भी बहुत बार ये चीज डिस्कस कर रखा है. सो इसको हम रिवर्स करेंगे. ओके, जैसे हम 1 से 2, 2 से 3, 3 से 4, 4 से 5, पर हम ट्रेस तो ऐसे उसको किए ना, फाइव से फोर, फोर से थ्री, थ्री से टू, टू से वन, से रिवर्स करेंगे इसको। ओके, चलो इसको कमेंट कर दे रहे हैं। सो या, बस अब यही साइकिल प्रिंट कर दो। सो सी आउट यस हैंडल, एंड आई गेस हैंडल नहीं, स्लैश एन यूज किया करो यार, तभी तुम असली कॉम्पिटिटिव प्रोग्रामर कहलाओगे। एंड फॉर ऑटो, वी, वी, वी साइकिल कुछ भी रख लो। सी आउट, कितनी बार भी है भाई? एक, दो, तीन, यही यही है आई गेस। ठीक है, डोंट यूज दिस इन इंटरव्यू, थोड़ा स्टैंडर्ड यूज करना, अदरवाइज दिक्कत हो सकती है। सो या, लेट्स ट्राई टू बिल्ड इट एंड सी क्या आ रहा है। ओके, getting some errors. What we're getting error? Let's use online GDB. Okay, you can just give me a second. Uh, yeah, online GDB is there, and let's just let's just wait, let's just copy it. And why can't I see it? Okay, here. So yeah, language is C plus plus 20 to 20. So I can shake. Yeah, so let's try to run it. Let's see what the compilation error we're getting. Reverse cycle.begin. Okay, you use comma, but you have to use dot here. Dot. Okay, what next? Ah, here you also use comma. You have to use dot. What next? Oh my God. U, V, and W. U was not declared in the scope. Who said U was not declared? Okay, ABC. ये तो गड़बड़ हो जाते हैं। गड़बड़ गड़बड़ गड़बड़। Okay, we got it. Control A, Control C. And where is my CS? Yes, here. Control V, Control S. Go to the problem, try to submit it, and choose the file. Let's CSES.cpp. I guess it was pretty much standard problem. Let's try to submit it. I think it should get accepted because obviously there is no much of a rocket science here. So yeah, got accepted. So you can say it's pretty much a variation of Bellman fault algorithm. Okay, so you should know the basics of Bellman fault. Okay, what is Bellman fault and why do we use it? And there's a little variation, sneaky peeky variation. You can read it here, Bellman fault on CP algorithms. Okay, so इधर दिया होगा कि इसका variation है ये. Yeah, this is Bellman fault retrieving path, the case of negative cycle, shortest path. So yeah, यही तो था इसमें जो हमने पढ़ा, that no negative cycle word in the presence of negative cycle, the further communication associated with the fact that distance of all the vertices cycle as well as distance to the vertices reachable from the cycle is not defined. And therefore, if you do not limit the number of phases then mass, the algorithm will run indefinitely, constantly improving. So hence you obtain the criterion for presence of cycle of negative ridge. After mass phase, you run algorithm on the phase and perform at least one relaxation in the graph in the negative cycle that is reachable from V. Or else the cycle does not exist. So yeah, I guess that is it. So we'll meet in the, I guess, next problem of day 13 of CSES. Yeah, so till then, keep solving, keep grinding, and yeah, bye bye.